Ready to go. Hi, everybody. Nice seeing you all. My name is Sasha, and I am the co-author of the upcoming book with my esteemed colleague Ivan Mrđio that you've probably seen over there. And I'm also currently working for the UN World Food Project that's called Share the Meal. So I have to do a bit of promotion here. We actually provide food to school children in need. Yesterday I think we reached 3 million meals shared. We were also announced as one of the best apps of 2015 2 days ago by Google. So if you want to go, go to the link, download the app, and help the kids. So I'm going to be talking about reactive, a bit more advanced stuff. So how many of you have never used RxJava in an app? Okay, but how many of you have never used Rx and haven't been to Ivan's presentation? Okay, that's cool. So I'm not going to spend that much time on the basics. RxJava is based on the observer pattern, or the particular implementation of it. So you have the observer, you have the observable, and you have the subscription. So those are the basic components of RxJava. So the subscription is, it has the relationship between the observer and the observable. So later we're going to talk about those, because they're very important for the life cycle, because you don't want to have everything just run forever. Then you have the subscriber, which isn't actually that much used outside of RxJava library. It's mostly used internally, which is the observer and the subscription. So you have a combination of those two classes. Why do we need to have this? Because then the observer can unsubscribe itself from the sequence. So, for example, in some calls, you might see that it actually takes the subscriber. So, for example, when you do subscribe, you can use the observer, but that observer is actually internally wrapped as a safe subscriber by RxJava. And you have a subject, which is a very important thing, because it puts together the observer and the observable. So even before I was talking about observables, so the observables are like using getters, so you will get the data. But how do you send the data that you want outside of the observable? So let's start with basic observable creation. So Ivan was already talking about what methods are there. So you have just and from, which are simple creation methods, but they're executed immediately upon creation. So they're executed immediately. So you have create, which is executed upon subscription. So you can actually defer the execution until you have a subscriber actually subscribing to the observable. And you also have defer, which is again executed upon subscription, but it's a bit simpler to use than create. And there isn't that much documentation about it available. So let's see how we can just simply create an observable. So you have observable, and it just returns just. So in this case, you can use, for example, shared preferences or something. This might actually not be the best example because it takes some time. So, and this is, as I said, executed when you arrive at that line in the code. So it will actually block the observable from continuing. So obviously you would want, to make it a bit better. So you have create, which, as you can see, is a bit complicated. So you also have the subscriber, which I was talking about. So now the thing with this is that RxJava doesn't provide you with anything when you use create. So you have to think about everything that's there. So in this case, and I actually copied Ivan's example, you have, sorry. You're Italian, you're used to stealing. Yeah. So obviously what to do, first we check if the subscriber is maybe unsubscribed in the meantime, then we send the value through on next, and then we again check if it's unsubscribed, and if it's not unsubscribed, we send on completed. So this is a bit complicated, and this is actually a simplified example. Because there are also some other things to consider. So for example, this is a very simple example that will completely break the create. because we were talking about unsubscribe before. There's also one thing that's called back pressure. So Ivan was talking about methods like sample, take, and that sort of stuff. So what are those kind of methods? Since you have a chain, there is also possibility of observer telling the observable that it cannot use all the data that it's sending. So, for example, sample is a nice thing. It will take maybe every 10th value from the observable or something. So, in this case that we have here, we actually have a loop that will just continue creating values. So what happens when you unsubscribe from this? Nothing happens. It just continues to send data, which probably isn't what we want to do. So if you want, you can go to David Karnok's blog. He is actually one of the writers of RxJava, and he explains this in much more detail. So basically, on create is very nice to use, but it's very powerful, and you don't have any protection from RxJava. You have to think about other stuff. So what do we use? We use defer, which is basically the same that we have in just. It just execute it on subscribe. So you still have, because just and from, they actually give you protection from subscriptions, back pressure, and everything else. So if you needed to do something like this, it's much better to use defer than to use create, because you will save yourself lots of problems. Because, as I said, if you use create, you can always use it in your application, so you know what are the limitations, because you know if you're not dealing with back pressure, that's okay. But if you're writing a library, people who are using it do not know, or if you have a big team, again, they do not know the limitations, and they use sample, and everything breaks. So there is also the special case of from. So Ivan, again, was talking about it. I know I'm citing him all the time. So it basically takes a list, then transforms that list into a list of events. So you have, like, for example, if you have a list of Boolean, if you use from, you will get a sequence of Boolean events. If you use just, you will just get a list. So you can see the difference in the subscribers. And now I'm going to use my fancy pointer. So the observer will be list of Boolean. In the case of just, in the case of from, it will be actually observable Boolean. And it will also, at the end, it will emit on completed, so the sequence will be finished. So why do we use this? Very simple. You use it to replace the for loop. So there is a thing that our colleague that we're writing a book with, Fabrizio, told us: if you see for or if in a reactive chain, you're using it wrong. So this is one of the things. So for example, we have a from list. So if you had a forEach loop that, for example, you did something like, for example, you want to change the value inside, or you want to change the whole object, you can easily do it with from. Then at the end, if you need again to have the data as a list, you can use toList, or you can use toSorted list, where you can also pass a comparator, so you will also get the sorting and everything else. So you don't need to use for loops ever again. So now let's talk about subjects. So subjects are a bit more complicated. They're a bit more powerful. So you've noticed that in all those observable creation methods, they are static initializers, static constructors. So you don't have any way to access the observable outside of the creation block. So that is obviously a bit of a problem, because if you just do very simple operations, like, for example, you get something from retrofit, or you read something from shared preferences, that's okay, but you might want to use that observable later to send some more data that's created later. So this is, subjects actually give you the enable you to communicate with the observer and to set the values to the observable. So they're basically like setters in basic Java. So you can access on next, on error, and on completed whenever you want. And actually you should, because that's why you're using them. So they're also thread safe, but you shouldn't mix threads. So basically the rule of multithreading in RxJava is don't use it if you don't explicitly need it. I'm going to talk a bit more about that later. So these are the hot observables. So basically you have, in RxJava you have the principles of cold and hot observables. So cold observables don't change the values outside of a subscription. So if there's nobody subscribed to them, they won't ever change the value. So for example, if you have observable.just1 subscribe, that one value doesn't exist outside of a subscriber. If there's no subscriber, there's no value, and that's it. Hot observables can change values even when there are no subscribers. So So later I'm going to be showing an example of a music player, which I'm sure the SoundCloud guys will appreciate. So basically, that's one of the things. For example, you have the service that plays the music, and you have the UI. So obviously, that music can keep playing even when the application is in the background. So that is the first example of a hot observable, because it's still there. You don't care about the changes at the moment, but then when you call the application back to the foreground, then you again need those values. So subjects are basically, subject is just an interface, and you have 4 implementations of subjects. So the first one and the simplest one is the publish subject. So this is like the basic hot observable. So it's like you're listening to the radio. If you haven't, if you missed a song on the radio, it's gone and that's it. So you cannot access that value anymore. It emits the values, who's there is there, who isn't. Then you have the behavior subject, which is it actually remembers the last value. So you can easily use it to cache if you do some network calls or something. So it will remember the last on next value. So for example, if the value changed and now you subscribe again to the subject, you will receive that last value. If in the meantime there was on error or on completed, it won't emit anything. So that's closed. There was an error in the meantime, you missed it. Who cares? One other thing is it can also be initialized with the value. So you can usually use behavior subject to initialize, for example, case of a music player. You don't need to think about the default state in the UI. You can just initialize, if you use behavior subject, you can initialize it with player stopped. When you subscribe your UI to the behavior subject, it will receive the default value, and you will be able to set the UI accordingly. Then you have the async subject, which is similar to the behavior subject because it remembers the last value. It's only that it will also resend the on error. So again, if there was an on error event in the meantime when you weren't subscribed, when you subscribe to it, you will receive it. So for example, if you had like some sort of backend transaction, you don't want to lose any possible errors that happen in the meantime. So you resubscribe to it. There was an error, you show the dialog or something, and everything's nice. Then you have the most important, the most complicated, and the biggest one is the replay subject. So it remembers everything. So whatever happened, you will get everything. So for example, if you were unsubscribed and you resubscribe, there were like 50 events, you will get all of them. There was an on error, you'll get that one too. There was an uncompleted, you will get that one too. That obviously poses a bit of a problem, like it's not usually nice to have the unlimited memory. So you can also, you have lots of creation methods. So you can create it with a limited buffer, with limited size, with time, with limited time and size. So you can basically do whatever you want. So let's now go to a simple music player example. So it's very simple player. It just has one button that has 2 states. So it has stopped or playing, and that's it. So this is just a basic state machine. So we have 2 states, stopped and playing, and you have the default, which is in this case open player, and it goes default to stopped. So the observer part we can easily solve. So we have the observer that says it receives the on the on next it receives a new state. If the state is playing, well, play the song. If it stopped, stop the song. So very simple, but there's that problem. How do we send the value to? How do we change the value of the observable? So that's so let's start with the code. So we have our basic enum that has 2 states, and we have the on next that will deal with the states. So that's the basic observer that we've seen previously. And this is how we actually create the state. So we have a subject. So we say, okay, this is a behavior subject, and it will initialize with the current player state, which we set as stopped. we subscribe a subject to the observer that we had previously. And then we have on press button, we say, okay, so if the current state is playing, send stop to the on next. If the current state is stopped, then send playing. So it's a very simple communication between the observer and the observable, so you can pilot the observable basically. So how can we simply optimize this small example? Well, we don't actually need to save current player state in a separate variable, because you have to think about synchronizing different values. So you can just basically get a value from any observable or subject just by calling getValue. Also, we have used subject, so this is an internal subject, so that's nice. If you want to expose that subject to somebody else, usually you don't want them to be able to send values to it. So you can just call as observable, and it will behave as a normal observable. So you will still have your observer there, but it will just react to the values. And one important stuff, you can use subscription to control the observer lifecycle. So let's talk about subscriptions. So as I said, there are relationships between the observer and the observable, and they are returned whenever you call subscribe. So for example, in this sequence, you can see you have a subject that's an observable, in this case. You call filter, it still returns an observable. You call map, it still returns an observable, but then you call subscribe and you have a subscription. So it is a very simple interface. You just have is unsubscribed and unsubscribe, and that's it. That's all you need to control. So in the examples that Ivan was showing, you didn't actually see this very much. This is actually a nice pattern, because now it's clear that you have a subscription. Because, for example, if you don't control the life cycle, what will happen if you call this 2 times? You might think that it might override this value, and that's probably true, but it will subscribe another subscription. So if you call this 2 or 3 times, you will have 2 or 3 subscriptions, and you will receive 2 or 3 times these values in your observer, which probably isn't what you want. So you have to control the life cycle of your observers. So I usually just do the UI stuff in activities and fragments, and I use external managers that do all the advanced stuff. So you wanted to, for example, you want to update the UI, then you obviously don't need to update the UI after on destroy. So in on destroy, you call, your first check is the subscription is now. If it's not now, is it unsubscribed? If it's not, then unsubscribe the motherfucker. Because that then releases the references, and Java can do its nice garbage collection. Otherwise, you will leak lots of memory. So you can also use this, as I said, to prevent multiple subscriptions or executions of the code. So in the case, for example, you want to subscribe to the player to start the UI, for example, on resume. Well, first check if it's unsubscribed. If it's not unsubscribed, then unsubscribe to it and resubscribe to it again. So you get the new reference. Also, for example, when you're doing network calls that can be executed from multiple points, for example, I don't know, get user. Well, in this case, check if the subscription is already there, because if the subscription is already there, that means that he's already executing that call. So in this case, just do nothing, because the calls are already there. You will get the value in your observer, and don't touch anything. Just feed the chicken. So if you don't want to do these now checks, like it's not now, it's now or something, you can also initialize the subscriptions. You have subscriptions empty. That's it. You also have the completed, but nobody cares about this. So one very important stuff is that this subscription is independent from the observable. So if your observable is a hot observable, it will still continue making values, but you just won't receive them. So if you have multiple subscribers to one observable, you unsubscribe this one, the others are still there. So that's still going. So what do you do? For example, you have an activity or a fragment, so you have multiple subscriptions. So you have, I don't know, subscriptions to the user, to the music player, to this and that. So how do you control all these? Well, you can easily do it with something that's called Composite Subscription. So you can easily For example, they have a nice, simple constructor where you just put all these subscriptions there. It will make one big subscription. You can also add to it at a later time. So, for example, this was in onCreate, in onResume, we want to add another one. Okay. So then on pause, we want to remove one of those subscriptions. Okay, there's remove. And then at the end, we say, okay, we don't care about this anymore. You just call unsubscribe, and it will unsubscribe all the subscriptions that you have in there. You can also call clear, which will unsubscribe and remove them from the object. So they're not referenced anymore. So that's an easy way to control all of them. So how do you control the life cycle? So you can do it manually, as I said, on the activity or the fragment level. You just unsubscribe whenever you want if you don't need it. So on pause if it's a UI stuff, on stop or in destroy if it's just a general data stuff. You can also do it automatically. So there is the Trello's Rx lifecycle library, which enables you to bind subscriptions to certain events. So for example, in this case, so you use it with Compose, which actually puts values together. So you say, okay, bind until event, and you say event pause or destroy or whatnot. You can also do it totally automatically. You just say bind to lifecycle, which means that if you call it from onResume, it will be destroyed, unsubscribed in onPause. Or if you call it from onCreate, it will be unsubscribed in onDestroy. But there is one simple thing, where one note, it doesn't actually call unsubscribe. For some technical reasons, they actually call onCompleted, which means that if on your observer you have some more advanced logic in the onCompleted, you cannot use this. So you have to do it manually. Also, there is one big thing of this library. It only works for activities and fragments. So it misses on one very big thing. You have another context in your application. You have the application context. So obviously, for example, if you do some network calls, or if you have a music player, you do not want that to depend on your activity, because activity might change. You may have multiple screens or whatnot. So you need to create a manager, which is something that Google guys very well know, and that will be bound to the application context. So, for example, that's something that you can easily do using Dagger, which I like very much. So then, for example, you would have an external manager that provides you with an observable. Then you will call that manager, say, okay, get me the observable. In onCreate, and then on destroy, you just unsubscribe. So the observable is independent from all this. So there is no automated way to do that, unfortunately. So you have to do it. You have to do that kind of control manually. But it actually saves you lots of precious resources or something, because, as I said, you don't have to recreate everything when you change activities. So it's a bit of a trade-off. So now I'm going to present you a little manager example. So it's a class that is actually bound to the application level, to the application context. So we'll call it user manager. So what it does, let's say it loads the user from saved preferences, because you probably have a user, you need it. But there is one more thing. So it also has a configuration. So what it does, okay, so we will get the current configuration observable. Then we do the flat map. We say, okay, we have the configuration. Now we need the user. Okay, and the observer takes this user and sends it to the user subject. So in your application, for example, in your activity, you don't need to think about the configuration. Configuration is needed to the manager. Activity just needs, for example, to receive a user. So you have a user, or you don't have a user, so you're not logged out. So this kind of logic belongs to the user manager, because that way you can reuse it in multiple activities, and the user will still be there even if you unsubscribe from it. So then we provide the user observable to whoever needs it by returning the subject and then as observable, because we don't want them to be able to send data to the subject. So this is fairly simple, but there is one thing maybe that's missing here. We don't have any checks or controls or error management whatsoever. Okay, so we would probably like to do some error handling. So one reason for that also, because when the on error is called, you receive the error data, and then the subscription is closed. So once you receive, once on-error event is sent through an observable, that observable doesn't exist anymore. It's closed. So you will not receive any more data. So what can you do? Well, you have these simple error handling methods. So on error return will, in case of error, just return another value. So on error will not get propagated outside of this method. You can also say, okay, on error resume next, which uses other observable. So the difference between these two is this uses a simple value, this actually uses an observable. So you can do other network calls or something else. And you have on exception resume next, which looks like it's the same as the others, but it's actually not, because the others use throwables and this uses exception. So this will filter out the exception, but still, if there is a throwable, it will send that through an error. So now let's see what we have here. So we have, again, we get the config. On error, well, we will probably propagate an empty configuration. So we will create an object that's empty, which serves just so we know that the configuration is not there, and we don't use on error to send it. So then we again do the flat map. Flat map again, on error, it returns an empty user, and that's it. So this on error, it handles all the errors in the chain. So for example, here I just used retro lambda. So you have actually 3 different calls. So here in subscribe you can use a complete observer that will handle all 3 methods, all 3, on next, on error, and on completed. You can also put just 2, which will be then on next and on error, or you can just put on next handler. But that would mean if you didn't have error management, it would just explode, because if it sends an error and there is nobody to manage the error, you will have a crash. So okay, so now we dealt with errors, but it's still not totally right, because here we send the empty configuration, but then we still load the user. So that's, you probably don't want to do that, because if you don't have a configuration, you don't want your application to start because there's nothing to start. So even if you have a user, it doesn't matter because there's nothing to do. So how do we do that? Well, we can introduce multiple subscriptions. Why would we want to do that? Because we can then easily use filter. So we have this observable. So as you remember, everything before the subscription is an observable. So now we extract the first part that we had here. So this part here, that's still an observable. So now we extract this into separate observable, and we use 2 different subscriptions. One where the configuration is valid. So we put filter, configuration is not null, and configuration is not empty. And the other one, which will say, okay, so this is an invalid configuration, in which case we check if it's really invalid, and then we just have something that will log or show an error or something. So this way we can easily filter out, and we have 2 subscriptions now, and each takes care of its own problem. So we have 2 separate chains. One deals with the configuration that is invalid, and the other one deals with the configuration that's valid, because they have 2 different life cycles, 2 different chains and everything. So you might have noticed that we have a logic that repeats a bit. So for example, here we have observable, so then we have the filter, but then we have this flat map, blah, 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 all that stuff. So what do we do with this? Because we have lots of repeating code, so that's not nice to see, and also you don't immediately see that they are the same. You have to read. You have a bit of a cognitive load there. So what do we do? Well, you have a transformer. So what does transformer do? Well, it takes one observable and then return something else. So why would you do that? Well, then you can use this to extract parts of the chain that are used elsewhere. So you can also return different types. As you can see, you can also return same types. So you say, okay, so this is the transformer that takes the configuration in, gets the user out. And we have always the same thing. So first we have the configuration observable, then we check if it's not now an empty, then we will do flat map, which shows the user, and then on error return. So then we can use this in 2 different subscriptions. So we use it by using compose, which you will now know because you have seen it already in Rx lifecycle. So we call this convert configuration to user, and we use it in 2 different subscriptions. So this is much more readable, I would say. So now we go to multithreading. So Ivan was already talking about multithreading a little bit, and some of you had very nice questions. So RxJava is asynchronous by default, but it's not multithreaded. So by default, all the methods are executed on the thread from which you called it, which probably isn't what you wanted, especially on Android, because you always had a problem with the UI thread and everything else. So you have a subscribe on method and the observable method. So subscribe on changes the upstream thread, which means that if we call it here, everything up to here will be executed on this schedule IO in this case. And we have the observable, which changes everything downstream, so after this one. It's important to know the principle, well, not important to know, it's nice to know the principle how it works. So they actually call it, when you create the observable, and they use something they call lift, which just assigns a certain thread. So it's not executed and it's actually called. So it's basically just a setter and says, okay, when you execute this, do it on this thread. Which means that also everything you call in between will still be called on this thread because we haven't changed it. So that answers one question that was there. What they actually say that this is not documented behavior because they didn't think about it before, because they just thought people need either to subscribe or to observe, but they don't want to use both of them, which on Android, you have to do, basically. So this actually works, but there were some tricky bugs a year before or something. So this is what you should use. So the names are a bit confusing because you have subscribe on, but that is not called by the subscribe, is not used by the subscribe method. And you have the observe on, which is now connected to the observer. So you have to, be careful, but this is it just becomes an automatic. You just write .subscribe on, .observe on, and it's a nice habit to have. So what kind of threads do we have? We have ones that are provided by the RxJava scheduler, and we have those provided by the RxAndroid library, which is basically main thread. So if you use it on Android, and I suppose most of you do, this is the one that you need to update the UI. Everything else is provided by the RxJava. So we have a few threads. So the most used are computation and IO. The difference between those two is that IO is unbounded, which means that if you call it 50 times, it will have 50 threads. Why? Because input-output, you don't care about it that much. I mean, you don't want to create 100 threads that do input-output because they'll be a bit slow, but they shouldn't be bound by anything. You have the computation, which is actually bound by the number of the CPU cores you have on the phone. So if you have 1 core CPU, if you have 1, if you have 4, it will have 4, if you have 8, it will have 8. So that's why for any manipulations or something, you should use computation, because it will be limited. So you get to use multiple cores, but you don't get to have 50 threads on 4-core CPU. You also have immediate, which execute immediately on the current thread. You have the trampoline, which is executed after the current work has been finished on the current thread again. You have the new thread, which creates a new thread. You can also use the custom executor. And there's also a nice thing that's called test. So it uses a test scheduler where you can schedule manually when the jobs are going to start. So if you want, to do some unit testing or just test what it does, you can easily do it. So don't think that multithreading now became easy, because it's still problematic. You will still have some crashes that are caused by one process that crashes something else on the other thread. It doesn't happen that often. It happens, and you debug for hours, and you have no idea what happened. So it's not easy, but it is a bit easier because you get lots more control, especially since we didn't talk about the methods that you have, which are, you also have schedule. So you can, schedule that starts immediately and is executed a number of times, or schedule that has a delay. So you get lots of control that you will have through Java, but it's just a bit easier. And one more thing. So do not specify the thread unless you really need to. So once I had a nice idea, like, I would in my manager, I would just specify immediately all the threads that I need. So it will be done on this thread and observed on this one and that sort of stuff. So then downstream, when you use it in some other activity or in some other manager that uses that manager, there are problems. So don't use it unless you need to. And the best place to actually use this is at the end. So for example, if you have your managers and they do all that sort of stuff, so only if you do I/O you will specify I/O, everything else will be done, you don't care. And then in the activity you say, okay, so do this on computation and observe it on UI thread, and it will make your life much easier. So now one other thing which isn't talked about that much, there's called the side effects. So what are the side effects? So those are the methods that are called when there are events in the chain, but they do not impact anything that goes elsewhere. So basically, you can do this. You have additional methods that you can easily do. For example, if you want to do some logging or something, so you would, for example, you have a do on each, which is called whenever any kind of event happens on the observable. And you can say, okay, do on each, and you just log what you have. So it doesn't impact this chain at all. It's not even synchronized or something. It just starts this and then goes immediately to the next one. So whatever happens. So you can use it for logging. You can also use it to do some data persistence, because, for example, if you get the new user from the network, you can just save it so you have it for later, but you don't need to actually have that value to know the outcome of the save method now, because you don't care. And then, so you also have, beyond on each, you also have on next, on error, and on completed, which will just be called in case those events happen. So you can do logging on do on each, so you know everything that happens, but you can also do it just in on error, and on the next does something else. So you also have helper methods, which are called when the chain of events management happens. So you have on subscribe, on unsubscribe. On request means whenever request for data is sent, which means that, for example, when you subscribe, the first thing that your observer does with the observable says, I need data. So it sends a request. So that's when we were talking previously about back pressure. So that's one of the things that they are behind in RxJava. You don't know about it until you really need to know about them. And you have on terminate, which is that everything's finished. So you use this to debug. So I won't be talking about debugging that much, because I actually didn't think I'm going to arrive at this slide. How to make your life easier, because as Ivan said, it requires a mindset change, because we're used to do imperative programming. So you just have, give me this, do this, after this, do this, then call this callback and everything. So it's not that easy to adapt to the idea of observing and just waiting for the data to arrive and modifying them. But then, you still sometimes want to do something. So if you have problems, you can use, as I said, side effects to do some easy logging. If you want to see what's really going on, you can use the RxJava debug plugin. So it works globally. So you just have RxJava plugins get instance. And you can use those hook methods, which already exist in RxJava. And you register your observable execution hook, which will then, on every method, it will do, for example, in this case, you will do logging. So it will be called on next, but you also start, complete, and error. So these are not start, complete, and error. These are not the observable calls. These are actually the internal RxJava calls. So if you use this in your application, you will see something like this. So if you really use RxJava, you will have thousands of lines of debug. So I've just quickly show you what this is so you don't get lost if you need to use it, because it's very nice for debugging, but it's a bit heavy. So what do you do? So it says you have start on, and it says observer, okay, and the type is subscribe, which means that somebody subscribed to the observer, or somebody started the subscribing to the observer. So then what happens? If somebody again started to do the request, which means it requested data from the observable. So then you can see complete. You can see again it was the observer and the type was request, which means that these two correspond. But you have some more data. For example, you have the thread ID, which is now useful if you do multi-thread debugging. So it means that it asked for the data from the observable, and the observable said, okay, I'm going to give you some data. So if you do your custom create something, custom operators, they're called, so you use observable.create, you want to implement back pressure, this is the stuff that you need to take care of. So then it says, okay, so I'm start, the type is on next, and here you have a value, which means that the observable now started sending those values to the observer. So now this is actually the only log call I have in my application, which just logs what comes in on next. So it says, okay, I'm logging my object, and this arrived. And then, again, this is the RxJava debug. It says, okay, so it has been completed. So this was the observer, and this is the on next. And this was the thread ID. You also have much more data here. For example, you also have from. So those are the internal operators. So it says operators as observable. So for example, if you use merge, you will have different operator here. If you use zip, you will again have different operator here. So it logs everything that goes on in RxJava. So it's nice tool to use, but only when you need to use it. So then coming back here, there's also the Frodo RxJava logging library, which was written by, I think, somebody very famous that's here in the room. Fernando Cejas. He also has a nice blog, so please go there and then read the stuff that's there. It's very useful. And you can obviously write your own RxJava plugin. So this debugging uses the observable execution hook. You also have the scheduler hook. You also have the error handlers. You can just write your own error handler if you want to. And that was it. So if you want to know more about RxJava, obviously you should go to the RxJava page. Also, lots of internal stuff was actually previously discussed on GitHub. So for example, the subscriber thing was introduced, I think, like in January 2014, and there is actually a nice discussion there in the issues, and they explain why and how and what's the purpose and blah, 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 blah. There is also the single, which is a new thing, which is still, I think, in experimental. It was also requested, I think, by Retrofit, because when you do network calls, you're just going to have one value. So you have all that discussion there, again, how and why and how it works, what are the problems and everything. If you want to know more about reactive programming in general, you have the ReactiveX homepage. You also have some interactive marble diagrams, so you can see if you see the Rx documentation, you will see marble diagrams which just show you what happens to the data. So there is an interactive page which is very nice and very useful for various operators to see what goes on. You also have Ben Christensen talks, so he is one of the writers of RxJava, and he explains it very nicely, and they're mostly beginner stuff. So, yeah, sorry, you have some competition. Yeah. Also, I wanted to talk about unit testing, but there wasn't enough time, so you can see some stuff here. It's not as easy as it looks, but it can be done, obviously. And there is David Karnok's Advanced RxJava blog, which I already mentioned. He's also one of the writers of RxJava. And it's that kind of stuff where you say, okay, so he talks for eight pages about something, and you read the first page, you say, okay, you arrive at the second page, you say, okay, I don't need this, and I'm probably never going to need it. Yeah. So if you think this is advanced, don't go there. No. Okay, so this was it. Any questions that I can ask? Thank you.